Okay, so we're starting with our review. On our review, our first 3 questions ask us to classify the triangles by the sides. Who can raise their hand and tell me how we classify the first one by its side? Cam?
Scalene.
How did you know it was scalene? None of the sides are equal, so we have scalene. We have triangle number 2. How would we classify that by its sides? Can someone raise their hand? Nemo? It's what?
Equilateral.
Equilateral. And triangle number 3, what would, Lucas?
Isosceles.
Isosceles. And how did you know it was isosceles?
Got 2 and 3 in action.
Yep. 2 of the sides are congruent. And we know with isosceles triangles, at least 2 of the sides are congruent. The next group, we are classifying by angle. So for question number 4, if we were going to classify that by angle, how would we classify it? Bella?
Acute.
And how did you know it was acute?
Because they're all less than 90.
Cute, because they're all less than 90. We have number 5. Cam?
Right angle.
How did you know?
Square.
Yep, that little square in the corner tells us it's a right angle. And then number 6. Nemo?
It's equal angular.
And how did you know that?
All the sides. Angles equal.
Okay, so we see that we have 3 congruent angles. Number 7 asks us to classify it by triangle, or by sides and by angles. So classify the triangle by sides and angles. Lucas?
Scalene, right?
And how did you know it was scalene?
Because all 3 sides don't match up.
Yep. All 3 sides don't match.
And there's a little square.
Exactly right.
Does it matter how you word?
You can call it right scalene or scalene right. Generally, I see it with the angle classification first and then the side classification. We also want to identify the sides opposite of each angle. So I'm going to set it up and just write out each of my angles. So I have angle P, I have angle N, I have angle Q, and then we did one like this previously. So we want the side that is opposite of these angles. So Cam, what side is opposite of angle P? NQ, and this is a segment. So we put the line over it. No arrows on the endpoints. Lucas, you're going to do side N.
PQ.
So for side N, it's going to be PQ. And for side angle Q, what side is it?
PN.
What did you say, Coda?
PN.
PN. Okay. Number 9 is the exact same setup. But now we have angles A, angle B, and angle C. So the side opposite of angle A is BC. The side opposite of B is AC. And the side opposite of C is AB. Again, since these are segments, we put the line without arrows over the top.
Oh, give us a countdown.
Okay, so it is restarted. So now we want to find the missing angle. So the missing angle in each of these is angle 1. Bless you. So how do we find the missing angle in angle 1? Can someone raise their hand to tell me? Yes, sir.
180, take away 73, and take away 28.
Yep, 180 minus 73 minus 28. And what value did you get? So we heard Rio tell us that this value here was what? 101. And Nemo, what did you tell me that ends up being? 79 degrees. So we had a theorem that tells us how to find the value of the exterior angle of a triangle. So with the exterior angle is equal to the sum of the 2 interior angles that are not adjacent to the exterior angle. So we find that 132 degrees equals the measure of angle 1 plus 57 degrees. We got to combine our like terms. We're going to subtract that 57 to the other side. We end up with the measure of angle 1 equals Do you guys agree with him? He says it's 75. Yes? So we see that it is 75 degrees. And then 12 is two triangles. And we see that we have two triangles. And in these two triangles, we know how to find the top of both of them. So we have a 90 degree and a 60 degree angle. What do we do with those? We can add them together. And when we add those together, what do we get? That gives us 150. So we're trying to find that remaining angle. How do I find that? We subtract it from what? We subtract it from, so 180 minus 150 gives me what value? 30 degrees. So right now we found this top angle is 30 degrees. We had to find that to be able to find the measure of angle 1. So if now we want to find the measure of angle 1, how do I go about that? Okay, so we now have 30 degrees for that top one. We're still looking for the measure of angle 1. We see that we have a 90 degree angle, we have a 30 degree angle. By the triangle sum corollary, that tells us if we have a triangle that has a right angle, the other two angles have to add up to 90. So I can just do the measure of angle 1 equals 90 degrees minus the angle that I have. The angle that I have is 30 degrees. So the measure of angle 1 has to be 60 degrees. So that is that portion. We have 4 more problems on the next side of our page. The bottom half I'm not having us do. So 17, 18, 19, and 20 you can cross right out. So for question number 13, it's the same design as the other ones with the exterior angles. So we know that the sum of the exterior angle, or the value of the exterior angle, is going to equal the sum of our two interior angles that are not adjacent to it. So we have 55 degrees plus x. We want to solve for that x, so I'm going to subtract 55. When I subtract 55 degrees from both sides, what value do I get? It's just going to be 55 degrees. So 110 minus 55 is 55. Here on number 14, we see we have 3 values for the interior angles of our triangle. And we have to rely on another knowledge that we know. That the sum of the interior angles of a triangle is how much? So 180. And if you forget this tomorrow on your quiz, you can see it focused on this page. Blue poster on the side. So we have 180 equals, Nemo, you want to finish that? Okay. So we have 180 equals 2x minus 3 plus 23 plus 128. So we're taking all the interior angles and we're adding them up. And we know that the sum of the interior angles has to be 180. So we have 180 equals 2x plus 148. You're right, Rito. And we're going to subtract 148 from both sides so we can get our like terms together, things without a variable. When we subtract 148, you get 32 equals 2x. We want to get that x by itself. We want to isolate our variable, so we're going to divide by 2. X equals 16. Do we have any questions so far? Okay, so we want to find the value of x for this question. And on the value of x for this question is an exterior angle. So we have the exterior angle of 6x, and it equals the sum of the two non-adjacent interior angles. So that's going to be 38 plus 82. We get 6x equals, what value do we get when we add those two together? 120. 120 divided by 6. X equals 20. We also have another triangle right here. Number 16 looks more complicated than it is, and there's 2 ways to go about solving it. Who would like to decide how we go about solving it?
What are the choices?
Well, you tell me how you want to begin, and I'll tell you which one we're doing. Ashley? Okay, so she's choosing us to work with the AEB triangle, and what we have to do there is we have to rely on the fact that we know the interior angles of a triangle add up to 180. So we're going to take 45 plus 50 plus 2x plus 5. we have 45 plus 50 plus 2x plus 5 equals 180. This is a really nice method to start with. So we combine our like terms, so we end up with 45 plus 5, which is 50, plus 50, which is 100. And then we have 2x equals 180. We want to combine those like terms, so we're going to subtract 100 to the other side. We end up with 2x equals 80. Divide by 2.
40.
X equals 40. But we're not done because now we have to find the value of y. So we know this here is 40 degrees. So we know again by that triangle sum corollary that if you have a right angle, the other two angles have to add up to 90 degrees. And so we can take 90 minus 40. Yes, you guys are both correct. Equals 50 equals y. So 50 degrees is our value of y. Okay, so our first one, we have a triangle that has two congruent angles, which we know by the theorem we learned yesterday that the opposite sides of an angle that are opposite part of a congruent. Nope, let's try it again. The side opposite of an angle that is congruent are going to be equal. So we have 13 equals 3x minus 5. We're going to add 5 to both sides. We're going to get 18 equals 3x. And we're going to divide by 3 on both sides. And Ethan, what did you get? X equals 6.
Where did you get 18 from? Like you said it equal to 18.
So we added 5 to both sides. And then 13 plus 5 is 18.
I see what you
Okay?
I just did mental math.
We see we have two congruent sides in the next one. And the angles opposite of two congruent sides are congruent. Gentlemen, what's happening back there? Okay, so that means these two are going to be congruent. So we have 55 equals 2x plus 1. We want to combine our like terms, the things that have x's, the things that don't. So we're going to subtract 1 to the other side. When we subtract 1, we get 54 equals 2x. We're going to divide by 2. It's not going to be 17. You're close. It's 27. So x equals 27. And our third one is just like our first one on this page, where we see we have angles that are congruent and the sides opposite of them have to be congruent. So we see that these sides are going to equal each other. So we get x plus 5 equals 4x minus 16. Combine our like terms. I'm going to zoom in. I have a minus x on both sides. I get 5 equals 3x minus 16. I'm going to add 16 to both sides. I end up with 21 equals 3x. We're going to divide by 3. X equals 7. Our next group is once again classifying. This time we're classifying by angles and by sides again. So we're going to classify triangle number 4. How would we classify this? Can someone raise their hand? Jake?
Obtuse isosceles.
Obtuse isosceles is correct. How did you know that?
Because it's got two congruent sides and it's obtuse.
Because the angle is greater than 90. You are correct. Can someone raise their hand to classify number 5? Cam?
We stay in unit cube
How did you know?
because none of the sides are the same, and then there's 85 degree ones where 90 supposed to be cube.
You're correct. Kaylin?
Right skin,
We have right scaling. And how did you know that?
because the little right angle sign is there and then the things are the same.
Yep, now the side lengths are equal. Looks perfect. Now we're finding again the measure of angle 1 and number 7. It's once again where we're looking for the interior angle. And we see that we have a right angle. So based on the triangle sum corollary, we have 90 degree angle, which means the other two angles equal 90. So we have 90 minus 60 equals 30. So the measure of angle 1 has to be 30 degrees. We also have question number 8. The numbers are a little oddly placed there. We want to find the sum of measure of angle 1. The measure of angle 1 is going to be the sum of the two angles that are non-adjacent to that exterior angle. So So that's going to be 40 plus 38. And you guys are correct. It's going to be 78. I write 70. I say 70. I write 30. So we have 78 degrees. And this is set up the same way. So we see that 150 equals 85 plus the measure of angle 1. We want to isolate the measure of angle 1. So we want to subtract 85 from both sides. Do we agree with him? Is it 65? Measure of angle 1 is 65 degrees. It's a little hard to see, so I will scroll down for our next. Okay, so here, which angle or which triangle is obtuse?
I put JLM.
Yep, so we're going to name triangles by 3 points, and you put the little triangle side, and it's going to be JLM.
And then for 11, I got KLJ.
KLJ.
And then for 12, I got JKL. And then,
Okay, you got to give me a second.
oh, my bad.
Okay, so you got the acute one, which was JLK. And then for equilateral, which one did you get, Ethan?
I put JKL.
JKL. So it's just a same way or different way to name the same triangle. And then we have an isosceles. Which ones are isosceles?
I wrote MLJ.
So triangle MLJ. We have one more. So the definition of isosceles is at least 2 congruent sides. So it can have more and still be considered to be an isosceles triangle.
JKL.
So again, it would be JKL. Because even though it's equilateral, it's still isosceles.
Wait, so it's not JLM too?
JLM and MLJ are just different ways to name the same triangle. It's just different order of the points.
Oh, you put both of them on.
We have number 14. And 14, once again, is looking for us to find the value of x. And we have the three angles in the interior of the triangle. So we end up with 180 equals 2x minus 3 plus x plus 3x minus 15. We're going to combine our like terms, so things with x's, things without x's. So 2x plus 3x is 6x. And then we have negative 3 minus 15. Negative 3 minus 15.
Negative 18.
Negative 18. We're going to add the 18 to the other side. We get 196 equals 6x. We'll divide by 6. X equals what value?
Something with 8. 8.
What'd you?
Somewhere.
So 196 divided by 33.
Divided by 33.
Oh, divided by 6.
32.6.
You know what the error is? Did you guys see my error? I made a math error. It happens.
Oh yeah, it's supposed to be 1.
That's why I said it should be something times.
198.
It should be divided by some times 8.
I just didn't carry that down, so I apologize.
That's 33. There you go.
So that's 33. I knew what the answer I was looking for was. So 33 degrees. And then we have number 15. We're looking for the x. The x is in the exterior angle of the triangle. So we have 12x equals 54 plus 78. When we add those two, what value do we get?
132.
132. We're going to divide by 12 because when I isolate our x,
11.
x equals 11. Our last one on this part of the page is number 16. And number 16 tells us that we want to find the value of x. It gives us 3 sides. We just had to choose 2 of them that we want to solve for. Nemo, how did you get that?
Because it has to be the same as the opposite.
So which ones did you set equal?
3x, 3x times 5 times 15, and 5 times 5 minus 10.
Okay, so he said it equals to 5x minus 10. Is that what you did? Which one did you do?
Okay, so, okay, yeah, okay, I guess you can say that. So 5x, x will equal 5 because 5 times 5 is 25 minus 10 equals 15.
So he chose this one. He then subtracted the negative or 5x to the other side. He ends up with, I'm bothered by this. Okay, never mind. Negative 2x equals negative 10.
And you know, two, well, it's positive. Which we
And it gives me a positive 5. Yes, thank you. I did this in my other classes. I just did 15 equals 3x. I divided by 3. 15 divided by 3 is 5, and that's how I solved that. Okay, so now we are going to do what we did yesterday using the Pythagorean Theorem. The Pythagorean Theorem tells us what?
C squared equals A squared plus B squared.
Exactly right. C squared equals A squared plus B squared, where C is the value of the hypotenuse, which is directly across from the right angle. So we end up with C squared equals 10 squared plus 24 squared. I'll do the easy one. C squared equals 100 plus what's 24 squared? 576. Be careful. He just multiplied. That's very common. But we want to make sure that we're squaring it. So we end up with 676. To get the inverse operation, because we're just interested in C, we're going to square root both sides. I have C equals, what's the square root of 676? 26? Thank you. We have our next one. Again, we're looking for C squared. So we have C squared equals 35 squared plus 12 squared. C squared equals, what is 35 squared? This is a big number.
Ooh, it's like
1,225 plus, and then the square of 12 is 144. We're going to combine those like terms. And we end up with
1,396. I mean 369. My bad.
You're fine. I didn't. 369. Okay, we're going to square root both sides because, again, that's the inverse operation of a square. C equals, what is the square root of 1,369? 37. And then number 19. Number 19 is going to be C squared equals 8 squared plus 15 squared. C squared equals 8 squared is 15 squared is 225. We add those together. We get C squared equals 289. Square root of 289 is?
Is that right?
Somebody else verify his work.
Do a random number at some
Yeah,
point.
right. It's right.
17.
Yeah. I'm a good guesser.
We're not trying to guess. We're trying to make sure that we know what we're
It
doing.
was an educated guess.
Okay, so now we're solving for our missing side lengths. So previously we did our hypotenuse, and now we are doing a leg. So we want to set it equal. So now we have a C, and we have B, and we have 89 squared equals A squared plus 39 squared. Okay, this is going to be a big number. 89 squared is
7,921.
7,900. Wow. Okay, equals A squared plus what's 39 squared?
1,521.
1,521.
Yep.
Thank you, ma'am. We're going to subtract that to the other side. We end up with 6,400 equals A squared. Again, we're looking just for that A, so we're going to square root both sides. A equals 80. We are again looking for C on this one because we see that the hypotenuse is what's missing. So C squared equals 10 squared plus 14 squared. C squared equals 100 plus what's 14 squared? Jake, I couldn't hear you. 196. We end up with C squared equals 296. We got to square root both sides. Is 296 a perfect square? What is it?
18.
Try it. Don't keep guessing. It's not a perfect square. This is where we go back to our radicals. We got to do 296. What has a buddy? How many times? What goes into 296? So let's start with 2. 2 goes into 296. How much? 148. 2 goes into that. How often?
2 and 1. 2 and 4. Oh my God.
No, you're fine. I appreciate the effort. 2 goes into 74. How many times? Is it?
37.
Goes into 37. Does anything go into 37? No, it's a prime number. What has a buddy? Goes on the outside. What doesn't have a buddy multiplies together, stays locked up. So 2 square root of 74. We have one more group of problems, 3 last ones, and I think we'll be able to finish them. Find the unknown side length and determine the length to form a Pythagorean triple if they perform a Pythagorean triple. So we're looking for c squared, or c here, so we have c squared equals 4 squared plus 6 squared, which equals 16 plus 36. 16 plus 36. You said it was 52?
Oh, wait. No.
So it's 52. Is 52 a perfect square? It is not. So we have the square root of 52. We want to see what goes into it. So what's something that goes into 52? 2. How many times does 2 go into 52? Bless you.
26 times.
How many?
26 times.
26. 2 goes into 26 13 times. 2s have buddies. They come out. What doesn't have a buddy is that 13. It stays locked up. We have the next one, which is going to be 24 squared equals 9 squared plus b squared. 24 squared is 576 equals 81 plus b squared. We're going to subtract 81. When I subtract 81, what do we get?
407. No.
You get 490.
495 equals b squared. Is 495 a perfect square? So we now have to do another radical. So we see that 495, and we divide, or we see that 5 goes into it. 5 goes into how many times? 99. 3 goes into 99.
33.
And then we get 3 and 11. What has buddies?
3.
What doesn't have a buddy?
5 and 11.
So 5 times 11 is 55. And then we have 24. 24 is 50 squared equals a squared plus 48 squared. 50 squared, 2,500 equals a squared plus, what is 48 squared? So that's going to be,
2,300.
thank you. We're going to subtract that to the other side. We end up with 196 equals a squared. We're going to square root both sides. A equals, what is the square root of 196?
196, 13.
Don't just guess.
There is no 14.
What is it? 14?
So close. 14?
Yeah.